What I've got now is a Windows 7 running on an Asus EE PC with a USB 7.1 sound decoder and the Elector card here. I simply switched it on and asked it to start calibrating. What this card offers is a variety of inputs on it for both different input filtering for different types of antennas, as well as an internal 5 megahertz calibration signal, which is very useful because it injects it right at the beginning of the chain, and that tells you can actually trace it right through to ensure the system is working properly. This is the most complex part of the screen output. It's showing you everything it can offer. Under normal conditions, though, you can go to the top here where it says Display and click on Standard, and you can just bring up the basics of what you're after. Obviously, the more you use it, one of the great virtues of this is you want to see the waveform, the channel display of the whole IF. So by bringing up the full display, you can see the 24 kilohertz waveband across the bottom, and then you can start using this to its advantage, because the whole point of this is you can now see the adjacent interfering signals and tune your band to actually put in the filters where you want to block individual artifacts. An extremely difficult problem if you don't have a visual display. So that's one of the virtues about this. When you switch to using it, you suddenly realize, wow, I can blot out that interfering signal just like that by putting a notch over there, and up comes the rest of the waveband. So that's the setup that I've got. What I'm going to show you is some of the configuration options to give you an idea of how versatile this program is. This program, incidentally, is called G8JCF SDR. Obviously written by a British ham, G8JCF. It's completely free, and it runs on Windows and Linux under Wine as well. So it's a magnificent program, and it's extremely versatile because it fills in that problem we had earlier on about how many cards can I work with, how many sound cards can I connect to. And it's that particular part of how many different SDR receiver cards I'll show you right now. On the bottom right is a button that says Config. This brings up a multi-tab display that allow you to make all the changes that you only usually do once when you set the card up. And as you can see on the SDR model, which is the top line here, I've got it set to the Elector 2007 card. But if I click on the down drop bar, you can see that there's a whole range of them in here that it will actually work with, probably 40. So this is a really clever piece of software because it knows the command set to talk to the individual memories and chips and things on here that have to do the clever work, the programmable oscillators and things like that. So that's why this is looks a complicated program, but it's probably the easiest one to actually learn to use, because whatever you build, you can just go to this particular option and set your particular sound card, and it solves 90% of the problem. The second...
Will it hack into your hard drive?
Hacking? No. Well, depends on hack. It is installed on your hard drive, yes, but it's not doing any damage. It's a perfectly safe piece of code. Right. Yes. Okay, so I'm back on the Elector card. Where I'll...
Infiltrate would be the better word, I think.
Yes, now the other parts you can set up is a ham-lib model, which I won't go into in this talk, because ham-lib is a whole new mechanism for actually being able to talk to your Yaesu or something like that with Kenwood over a CAT cable, and you can actually do remote control checks with that. So it's got all sorts of open-ended things for it. The next part you actually have to understand, and this is difficult for people who probably haven't wrestled with Windows internals too much, is, and same with every PC, is how do the sound buses work inside of your computer? Because you've got two sound buses to use here. The first one, you've got to get the sound from this, out of here, into the here, which is on the stereo cable, and then it comes in on the USB. That's got to be processed by the DSPs inside this box. So you then have to get that particular channel on from that USB circuit all the way through to the input of the G8JCF program to use. When it's finished its processing, you want to take it out and send it to the loudspeaker circuit. the audio mixer side of your computer. Now, that is difficult for people who haven't done much of that side of it to get to terms with, because you tend to think the computer's got one sound thing in and that's it. But you do need to understand the multiple layering that Microsoft Windows does have inside, and in fact Linux as well, that you have to be able to process and individually manipulate the sound streams both into these programs and out of them to different destinations. So that's what it's showing here on this particular part. This is the sound card option, and it's asking you where does your AF output go to, your audio frequency output, and you obviously want it to go to the main sound device. But you could send it off to a headphone socket or any other external adapters that you have if you've got a big desktop computer. The next one is where do you bring in your AIF input device? And this you have to know by where you pick up the naming convention for what this thing does with the Windows drivers. Depending on your knowledge of Windows and device drivers and so on, I can't tell you, if you don't know much about this, take a month aside to learn it, because you'll need to know it, otherwise you switch it on and the whole thing just howls around, because you're feeding the output straight back to the input, and so it goes on and on and on. And all you see is everything going through the top of the graph, and it's not a very pretty display. So find someone to talk to about this, me, if I can be of any use, because you do need to get to grips with the fact there's multiple architectures of sound going on inside here. The next one that's quite useful to look at is serial interface. This allows you to customize what particular COM port you're using to talk to this. And that's something, once again, you need to know in your device driver setups for Windows. After that, though, it's very much a straightforward thing to get the basic service running. The sound card allows you, on the third and fourth lines, to play with the phase correction and the gain correction. Now, this goes back to the I and Q signals. One of the problems of building circuits that operate at these high frequencies is you've got to guarantee constant phase shifting across the bands that you're operating on. So if you build an electronic circuit of some kind, which is doing some kind of phase shifting or amplification or filtering or anything else you want, you must be able to guarantee you phase shift the same amount for all the signals in that particular card. If you don't, you're going to end up with really weird effects. And how to get around that is a major problem for software designers. But they bring it up on the screen in such a way that you can actually apply compensation to one of these inputs to shift the differential gain or the differential phase very, very slightly on each one. And that's what I'm going to show you here as to how you do this to null out the unwanted frequency. Because what would go back to the message we had about this image frequency we're trying to get rid of, just 24 kilohertz away. What we're looking at on the screen then is, I'll just slide this one out of the way. What we're looking at on the screen is a 24 kilohertz display going across. There's my 5 meg calibration signal. It's on the 5000. Over here is the image frequency. The nasty one I didn't want. And just to give you an idea, I'll use the buttons on here to mistune it when you normally set this up. Can you see the image frequency appearing? When you first start this thing up, you find that you normally have something ghastly, like 2 equal strength signals. You're now going to use this clever part of the software, and I can't believe it's all free, to actually use this program to adjust these differential signals of phase and gain. And you just simply do it through this interface of picking off the 2 little things here on the top. Adjust one, just like you used to do with L and C on a normal tuner. Get the best for the L, best for the C, back to the L, back to the C. That's what you're doing here, except it's all being done with software adjustments. So I pick off the little button and top here. I haven't got a mouse on this, so I'm a bit slow. And as I bring it down, what I'm going to try and do is, that's on about 0 at the top there, so I'm going to try and get it all the way down, and you'll be able to see how amazing that I can separate out at 5 megs, that I can bring down the image signal such a long way into the noise. And you try and do that with L's and C's. And a Butterworth filter with less than 20 nodes. Okay. Right, here we go. So we're now down about 40 dBs. Then we'll try the one here. There we go. And I think I've just about got it down almost to 40, almost 50 dBs. And that image is now in the noise. And that's what you get for being able to do things with software. It does in a way embarrass you because you've learned around in your whole life, you've spent learning L's and C's and tuning and filters and all of it so hard. You can do it all so well. And then suddenly along comes this. And you think, well, what's the point? You know? But you're actually now simply sending special signals and control signals to the digital signal processor chips in the components here to actually make this happen. And you're now ready, actually, to start listening to the radio. So I'll put another pause and I'll connect up an antenna. So.